videos, images, and 2 side screens. We got lights.
What are you talking about?
Set the atmosphere. Church.
Oh. Ooh.
Christy's been, she came.
You got lights?
Yeah, never mind.
What
In the building, it's gone.
Alright, so let's work this. Let's keep going. Number 63.
Let me get my trusty.
So a descent vehicle landing on Mars has a vertical velocity towards the surface of Mars of 5.5 meters per second. So I know there's a vertical and it's descending, so I'm going to do this. This is 5.5 meters per second. At the same time, it has a horizontal velocity of 3.5 meters per second. So
So
3.5.
We go from the arrow to the other arrow.
Yeah, because these are vectors.
Tip to tail. I know.
Tip to tail.
What's the tail?
The tip of the arrow touches.
At what
the
speed does the vehicle move towards its descent path? So what we're trying to find is this right here.
That sounded like gross. My nose catches
Alright.
something.
Have you had fried chicken in here?
I have not had fried chicken.
Have you had chicken though?
I've had grilled chicken.
I knew I smelled chicken. I just figured it'd be fried. I figured you'd be a fried chicken kind of man.
Because I'm fat.
No, because you're a
Thanks,
church-going
man.
person. Every church person eats fried chicken.
Every
I mean, I will eat fried
stereotype.
chicken. Me and my wife prefer grilled chicken. I like to
Ew.
grill a lot of stuff.
That's grilled.
Okay, but you had chicken in this room.
Grilled chicken
Yeah,
is
grilled chicken is
disgusting.
gross.
Okay,
I
have you
disagree.
actually grilled your own chicken, or
Yeah.
you talking you went down to Mickey D's and got a grilled
No,
chicken
we
sandwich? Because that ain't even really
No,
grilled.
yeah.
Grilled our
Grilled
chicken.
That ain't even
is
really chicken.
nasty.
What are you
It's
talking
either
about?
slimy and like rubbery,
Yeah.
or it's like
Blech.
dry.
Blech.
Y'all ain't doing it right then.
Well,
Can you fix this up?
Mr. Hall, you going down to Mickey D's? It ain't even real chicken. What are you
hey,
talking
have
about?
y'all tried that spicy chicken sandwich at McDonald's?
Alright,
Yeah,
so-
it is, but it's, oh my god.
We're trying to find this here. We're trying to find the velocity of the descent path, so you guys can pretty much figure it out. We're going to find this right here. I'm just going to call it V.
Ain't that like
Velocity.
A plus B?
Booyah. So if you guys got that, I'm just going to jump the gun here.
Why you
Oh,
telling me
what did you
that?
already do? This is just a commercial.
Okay, well, what are you doing?
That ain't ring theorem.
Well, why you putting them in the radical?
Because that would be squared, so then I have to take the square root of both sides.
Can I just do the
Why
Pythagorean
the
theorem for this
V?
step?
Because I just called that V. It's the velocity.
Right,
It's the
C.
velocity of its
It could be
descent
C.
path.
Can I just do the Pythagorean
You're
theorem for
calling it.
this instead of doing that?
Yeah.
That's what I was saying.
I mean, I understand it's the same exact thing. It just doesn't click in my head.
Yeah, that's fine. I don't
Okay.
care.
Okay.
I just jumping the gun, so I don't have to write so much.
Okay.
So is that 5.5? Is that the down, or is that like the?
That's it down.
Oh, okay, I got you.
That's vertical.
Perfect. There.
Honestly, I understand this more than I did the one before.
You got wires on
Yeah.
it.
That, I think we should just skip that.
All right, I need you to
I
give
agree.
me a calculator, please, and thank you, sir.
Did you hear me, Mr. Ross?
I already got them all.
Bet you were looking forward to the quiz. Yeah, I heard you.
Why are these
Thank
kids
you.
just skipping class?
All right, so 6.5, 192 meters per second.
Mr. Ross, I don't like these boys staring at me out here.
Christy.
Go get them. Tell them to skip in class.
Part B. At what angle with the vertical is this path? So this is A.
Wait, is that 6.5?
Yeah. I'm going to go to B.
Oh, what's the?
We got to find an angle. So we're trying to find this angle here of its descent path. So let's call it theta. So if I did the tan of theta,
Why you?
be equal to the opposite divided by the adjacent.
Mr. Hall, how do you know what one to use, like tangent, tangent?
You can actually, where you have all three sides now, you can choose whichever one you want. I just did tangent because I have the legs. I don't like to use something that I've made a calculation in, because if I've made a calculation in it, then I could have made a mistake. Now there's more mistakes going down the line.
Okay.
So I'm trying to find theta, so I'm going to do the inverse. So equals inverse tan. So 3.5 meters per second divided by 5.5 meters per second. Inverse tan, 3.5, 5.5. We'll get 32.4712. That is degrees.
So what, which angle is this to talk on?
Oh,
Yeah, it's going to be this one here because it wants the angle of its descent
I'm
back.
a little confused.
Okay.
Why are we using the tan negative?
Because you got to find the angle. That's what you're looking for. Yours.
So anytime we find the angle, we're going to use the negative once.
Yeah.
Of the
It's the inverse. Okay, what's the inverse of multiplication? Division. It's kind of like in trigonometric functions. It's kind of like the same thing.
Okay.
It's the opposite of it.
Okay.
Then part C is a really good question. If it was 230 meters above the surface, how long until it reaches the surface?
It was what?
How long until it reaches the surface? Alright, so in this case, we know we are 230 meters above, so this is all dealing in the y direction. So we only deal with the y direction component. The good thing of it is we kind of was given some stuff right there with that 5.5 meters per second, because that is our velocity, which we can call initial.
See, that's what I was going to write down. I mean, when you first said it was initial. Could
So
we do it
then-
that way?
Do what?
Could we write it down that way at first instead of doing that angle thing?
I mean, you can do initial velocity. No, you have to do the angles.
Oh.
So get that initial velocity. We can also say that the initial position is 0 meters. Then the final position is equal to, what was it, 230? Yeah, 230 meters above. So that's 230 meters.
Why do you put
Oh,
y
don't do this
instead
to
of
me.
x?
Do what?
Does it matter if we put x instead of the y?
No, it don't matter.
Not technically.
Where'd you get 230?
Hello?
They're spying on
Where'd you get 230?
That came from the problem. Okay, I guess I didn't do anything. So acceleration, in this case, is going to be 0 meters per second squared. And the reason I know this is this thing is not speeding
you.
up
They should not.
or slowing down. It's holding that velocity. So the acceleration of it is 0. It's fighting gravity. But we're trying to find time. So in this, easiest thing to do, y final equals y initial plus the initial velocity times time plus 1/2 acceleration times time squared. Acceleration is 0, therefore this cancels out and leaves me with y final equals y initial plus the initial velocity times time. Now I gotta get time by itself. So time will be equal to
Can we go
y
ahead and
final.
get rid of y initial too?
Boom. Because it's 0, we can't. Yeah.
Okay.
Okay, so y final minus divided by the initial velocity. So Y final was 230 meters. We're going to divide that by the initial velocity, which we have is 5.5 meters per second. Oh.
Why did you mark out the 1/2 AT?
Because acceleration is 0.
Okay.
So this will be equal to 41.818. Oh, 8182. Boom. Yeah, yes.
Oh, hold on. Why would we use the 5.5?
Because we're
That's our
dealing with the
initial.
Y direction.
I understand that, but it's also going in the X direction too.
Yeah, but what's going to determine when it's stopping the Y direction?
Yeah,
It'll
Connor.
keep going in the X direction forever until the Y direction stops it.
Okay.
Go ahead, Connor. Go ahead and say it.
What?
It's like my hair.
Actually.
No, I'm just confused.
Questions?
Cause like, wouldn't it take longer for us since it's like actually traveling like diagonally? Wouldn't it take longer to get from here to here if you're going this way instead of just coming down?
Yeah, but whenever you look at it, they already gave it to us in the problem when they gave us the legs. They already took that velocity of that path and broke it into the legs of the triangle, so I can just look. I'm looking and saying over this amount of time, it's traveling this fast. And the Y direction is traveling this fast in the X direction. Instead of just looking and saying it's traveling just like this, I can look and say that it's traveling like this and this. You add them together to get that. That's why we break it apart. Because you won't be able, with the math that we know, you won't be able to solve with the direction pathway.
Okay.
I just had trouble with the units, like how do you determine what the units are for? Like meters per second and seconds.
Meters are for displacement, meters per second are velocity, meters per second squared is acceleration, seconds is time. Kilogram is mass, newtons is force.
So anytime it's like velocity, it's gonna be meters.
Per second.
S equals D over T.
But if it's like X initial, then it's meters.
You lost me.
Yeah, because that's a position.
S equals D over T.
And then when you're like times it by.
Wait, what?
It'd be
when
D
you're, like,
over
timesing it by
S.
something,
T
don't
equals
you
D
cancel
over
it
S.
out?
Yes, but in this case, how this thing's going, it's kind of like, so like here, at these units, you really got meters divided by meters per second. Anytime you're dividing by a fraction, what do? Multiply by the reciprocal. So it's meters over 1, take the reciprocal of this. Seconds over meters.
What if,
So meters cancel to leave you
Snatched
with
them.
seconds.
what if they was both meters per second? Would they both cancel?
And you're dividing them?
Like if 230 was 230 meters per second divided by 5.5 meters per second. Would it just be meters per second or would they cancel?
They're canceled.
So you just do that with nothing?
Yeah, you can have units. But you're not going to end up with that.
Like,
If you end up with that, you've messed up somewhere. Unless I clearly tell you, okay, like your friction coefficients, those do not have units.
see, like up at where we done the tan -1, how it says 3.5 meters per second divided by 5.5 meters per second.
Yes, and meters per second canceled out.
Okay. Then what would be the unit with the 32.47?
Degrees. That's an angle.
Okay.
Good question.
If we have time at the end of class, can I show you conspiracy theory?
Oh.
Is it the one we've done? Yeah. You wanna see this one?
All right, so three forces. All right, speaking of that, I watched a TikTok video that talked about conspiracy theory in Marvel. So you guys watch Marvel movies, right?
Yeah.
So you know from Age of Ultron
No,
where they're all messing around trying to lift Mjolnir,
no.
and
Mjolnir.
Captain America like kind of budged it,
Mhm.
but he couldn't.
Oh.
So, so he wasn't worthy.
Mhm.
When's the next time that he met Mjolnir at Endgame and he was worthy? What changed?
Friction.
What changed was that Captain America knew the truth about Tony Stark's parents and how they died as a Winter Soldier, and he never told him. But then in Civil War, all comes out. So all of that comes out. He comes clean,
He tells the truth.
tells the truth about it. He is instantly worthy. I was like, whoa.
See, this conspiracy theory I'm talking about will absolutely change.
It's
your perspective
10
on
times
it.
better than that one. Like 10 to like.
Well, isn't there
Like, you thought you knew
isn't there
conspiracy
a new
theories?
Captain
No.
America movie like where he like dies or whatever after he
Is
gives
it?
that shield to that man?
Bull crap.
What?
Not that. Not
It's a
that.
TV show.
Nah. No.
That wasn't any one.
All right.
I mean, it was.
Or
but-
just ignore me. I mean, that's
Dude.
good too.
So number 64, three forces are acting on the ring in figure 23. What is the net force acting on the ring? So we gotta find the net force. Now the good thing of this is, so we kind of got like force one. If you look there, it's straight on the x-axis. So that is 64 newtons. And that's straight up x direction. Force two is also straight up x direction. And it's 128 newtons, but it's in the negative direction, negative x-axis. So I'm going to say negative 128 newtons. Now, here's where the fun kicks in. We have a third force that is equal to 128 newtons, but it's at an angle of 30 degrees. So we're looking at 128 newtons at 30 degrees. So now in this, we want to find the net force. So in order for us to find this net force, we are going to have to set this thing up, break it into its component vectors, and then from there, we can find our net force. So in this case, we got to find out what the force in the y direction here is of this triangle. And to do that, realize that this is opposite. So, which function, trig function will we use? Sine. So the sine of 30 degrees is equal to opposite, so f sub y, divided by hypotenuse, which is 128 newtons. So we'll find f sub y to be equal to 128 newtons times the sine of 30 degrees
64.
newtons. So we find that to be 64 newtons. Now, we're not done because this force also has something going in the x direction. So we have to find force in this x direction. So to do that, look here, here's this force in this x direction on this side. What trig function are we going to use on that?
The dagger root here.
Cosine. So cosine 30 degrees is equal to the adjacent, just f sub x, divided by hypotenuse, which is 128 newtons. So then we have f sub x will be equal to
110.85.
128 newtons times cosine of 30 degrees.
So anytime we're finding a side, we don't have to use the -1.
No, if you're doing a side, you do not do inverse function.
Okay. But if you're doing angle, you do.
Yes. And make sure you're in degrees. Because if not, your numbers are going to be all jacked up. So I get 110.851
3.
3 newtons.
Okay, so I did this with Pythagorean theorem. Does that work?
You can.
Okay.
You got 2 sides, you find the third.
That's easier on the brain.
You just have,
Oh.
you have to use trig to get one up.
Okay, is that all of this problem?
Do what?
Is that all this problem?
No. You gotta find the net force. We haven't found the net force.
Is that where you add them all together?
Yeah.
Well, that's easy.
So we gotta find net force. Let's do y direction first. So what's the net force in the y direction?
64.
It's just 64 newtons.
Is that all?
Yeah, because the only thing acting is acting in the y direction was this force here, this 128. So we broke it into its y and x components, and this right here is the y component. It's the only thing acting in the y direction, so it's 64. But then for the net force in the x direction,
That'd be 128 plus the,
not 128,
oh, now I know.
it'd be negative 128.
Wow.
Because that one's going in the negative direction.
Sneaky.
I didn't see it.
This is a way to keep it all together.
I
I
thought
didn't
a
see the
hypotenuse
negative.
couldn't be that good.
I'm confused.
This isn't a hypotenuse.
Why would that be F net Y?
No, y'all are sitting here, that's the book, so.
Right there's the hypotenuse, you got it right on there.
Yeah, there's the hypotenuse, but there's 128 Newton force going in the negative x direction. Open your books.
That makes more sense. Maybe
What is this 64 in the net Y? Where do you get 64 going in the Y direction?
Because you broke it apart.
Why?
We just did that part.
maybe
Force of
why-
y.
maybe if you-
There is no other forces going in the y direction except that
Mr.
force.
Oh,
Yeah.
that force
Oh.
is
Actually,
Maybe you can pay
Actually, that
attention.
not
force-
64.
Yeah, so
that
what
force is
you
not
follow.
64, it's actually
It's
78.263 newtons.
Or you can
Wouldn't it?
ask
Actually.
Mr. Hall, sine is opposite
We
of here.
add,
Yeah,
we add.
30 degrees. Opposite. Opposite and hypotenuse.
But in the book it has 64 along the x-axis.
That's wrong.
That's the first force I labeled.
Yeah. Going on in the x direction.
That's the third force. There's 3 forces.
There's
Are we-
64 on the x, negative 128 also on the x, and then that 128 in the,
First quadrant.
yeah.
So then you gotta break what's in that 128 is in first quadrant into the x and the y components.
The x component would be the 64, the y component would be the 110.
No, it wouldn't. That's a different force. The x component is 110.8513 newtons. Kids struggle with this every year. I understand. You see the 64 there and you want to say that that's the side of that triangle. It is
No,
not.
I want to
That
say
is a
that
force.
because that triangle matches the triangle in here.
That is not a triangle. That's 2 separate forces. Look, they don't have a legs in the y direction.
Yeah, I drew one.
Don't fit. Because look, if you drew a leg on those 2 forces, it's not a right triangle.
Right,
Isosceles.
that's correct.
Mr. Hall, are we gonna add 110.8?
No, it wouldn't be isosceles. It'd be a
whatever to that,
30, 60, 90.
to the next?
Still wouldn't be 3069.
No, it wouldn't be.
This one is.
It's 30, 60,
But I'm
90.
saying on this, not that. That's not the triangle I'm talking. When I'm talking with you, I'm talking right here. So you're talking this 64 Newton
Yeah.
force. You got your 728 Newton force.
Yeah,
This is not a leg of this. This is a separate force entirely.
So it's just put on there?
So if you draw a line on this, so if you drew this other leg,
yeah.
that's not a right triangle.
I see.
They're separate.
It would be sick.
So, Mr. Hall,
What?
on the net force X, are we gonna add
It
that
doesn't make
negative
sense.
128?
Yes.
It's okay, buddy.
You don't get it either.
Yeah, I do, thank you very much.
So we're adding there 128
Yeah,
newtons
dude.
plus the 64 newtons of that first force plus 110.8513 newtons.
Okay, so we gotta add 64 too?
Yeah, 'cause it's going in the X direction.
That was one of the lines.
So then what is B? Like why
That
do
64 is going in the Y direction. This 64 is going in the X direction.
I'll tell
Y'all still think this is easier than 1D?
then why does it matter if we get the 110?
Because it's going in the X direction.
You know what? I can,
Sounds like a whole lot of humming.
What in tarnation? Mr. Hall, no, I don't believe so.
I mean,
I promise you it is.
No. Mm-mm.
I don't agree no more.
This is incorrect. This
You
is
got people coming
a
now.
bunch of
Hey,
Hall
Mr.
bull.
Hall,
Ask
So,
a few questions.
would you happen to have a clear ruler?
Oh my god.
Please, Mr. Are you sure?
It'll
Like,
say
could you
Michigan
check?
Heating and
Oh,
Okay, so,
What you do?
okay, so we were trying to get a pop stuck out of the pop machine, and it was working really well. And we needed a ruler, so Brayden went and got a ruler
Miss
from
G
MG,
told
and she
Brayden if-
specifically said, don't break it.
She said
And a
she
little
gonna
bit of
be
that
like-
happened, and it broke.
See,
Alright, boys, this is what I'm going to suggest to you.
oh.
I would go to the CIS room. It's across from G's room.
Yep.
And I would ask them if they have any rulers.
Is that Miss Brownie's room?
Yes.
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 Okay.
Before you go, how about you just check back in the rooms? We're not doing anything that needs to be rushed.
They
here.
can't touch anything in the lab, Thomas.
Why?
why can't they?
Guys, I get where y'all come from. This is where I'm saying, like, everything to you right now, you're like, oh, 2D is easier than 1D. It all makes sense. Now you're starting to see what 2D is. You have to separate things out, and you have to keep track of it. Just because this is 64 and this is 64, they're two separate forces.
Yeah.
They're not the same.
I think it would help.
So if you wouldn't have added this, you would be wrong.
Now can we just change that
No,
number
I
to
just
like
don't get
65?
how-
That'd be so much easier.
The
Uh,
110
Are they always
is in
gonna be
the
the
X
same?
direction.
Do you need me to, like, help
No,
you?
first.
Okay,
I'm
what's
trying to be nice.
literally
I
what you're
understand
looking
trying to
at.
help.
This right here, this is the 128 newtons. So I'm applying that force at a 30-degree angle. You got that? You got that?
Got that.
Okay. In that, I can't solve that with that hypotenuse. I have to have X and Y components. So I break that one force into two components.
Do you understand now?
It clicked in my head.
Well,
And
it
the
ain't
reason why is
clicking in
because
mine.
in my head, the 64 was going with that bottom leg, and I had to separate that entirely, which is what you said earlier, I think.
What?
That's literally exactly what you said. I just had to do it for myself in my head and
So
cover
there's
up the
two
64
64s there.
and
There's
realize
two 64s.
that's the resultant vector.
Why don't
That's the
they
resultant
say
vector.
that?
You have to get the X and the Y, and then the X direction
Would you quit
is
that?
64 negative that, and then that, and then I still don't get the Y. Yeah. Yeah.
Oh, you stress me out more
I
than
got
he
you.
does.
I got you.
Okay,
Here
good.
with you, fall.
You're good, good.
Well, I
Good.
don't
Okay,
because
what?
I'm stupid.
You're not stupid. Just ask a question.
I've been trying to ask questions, but he won't shut up over there.
I answered.
I'm gonna fight you.
Well, I done forgot what I was saying. There's two 64s.
Yes, there's two
Why?
64 Newton forces.
Okay, and then there's two 128s.
Yes, but the one 128 we break in the component vectors because it's at an angle.
And it has to be negative.
No, the other one's negative because it's going in the negative X direction. Did you open your book yet? No!
That's so
Open the book!
Oh my God, I get it.
I don't.
See, Thomas? See?
There's
So
a
why don't
neutral
they
gap.
put negative
There is.
on that one?
You have
Because
to
it's going
notice
in the
that
negative
it's like
direction. Remember, vectors.
This
They
the
forces
resultant
are
vector, and we
vectors.
were using the X and the
The
Y.
positive and
And then-
negative tells you sign.
Yeah.
They won't assign it that. They're putting it on a Cartesian system so you can see how it breaks in 360 degrees.
Oh.
So in this, you see this is going in the negative x direction. And also, they do it this way because if I wanted to and I wanted to get really dumb with myself, I can make this a positive direction and that in a negative direction.
No,
Well, that would have made.
okay, so
They went
where,
on ahead and labeled it for positive x because they're like, everybody's going to stick with it this way, which makes sense.
where is the other 64?
It's in here,
I
it's
see
in
one
this.
64, not 2.
Because you had to do math. You had to use your trig to break it apart. You had to take this force. It's the resultant vector.
Okay.
You have to break it apart.
Okay, so we found this part.
Yes! Thank you, Jesus!
Okay.
Hallelujah!
I still got more 6 now.
Alright, good class.
And that's
Let's
why
mark-
we're
mark
only
that
adding
now.
164 and not 2 64s.
Yes! Because that 164 is in the y direction.
Math is
The other
power.
64 is in the x direction.
Got that now.
Math is power.
Now!
No, no more.
How about to go?
Yeah. It's time to go. I've
It's
not
about 4 minutes.
heard
4 minutes.
Yeah, that's 4 minutes that we're going to finish this problem.
I've not
Hallelujah.
heard
It's
enough.
not finished.
No, we haven't found it. We found the components of the net force.
Oh my God.
You haven't found the net force.
So we add 46 point whatever and 64 together.
You did that right there.
Uh-uh. Oh. So there's 2 different net forces?
The components. There's only one net force, but there's 2 components of that net force.
What do you mean?
Okay, we
You
don't
have an
know.
x component and a y component. Then we're getting ready to join them together.
What that means?
Okay, this is what it means. Look here, x direction. So, net force in the x direction. That's the net force x component.
It's like
What do you get?
46 whatever.
85.
Okay, so in this case, you're going to start here at the origin like you always have.
And make that line 46?
And now you're going to go 46.
Okay.
So this is 46.8513 newtons. X direction, and it's positive, so it's in the positive x direction.
64.
Now, you have the net force y component. Right here, the 64. So now you're going to go up
Oh, on that side.
64 newtons. The reason you went up is because up is the positive direction for the y. It was positive. Now, what we're looking for is this guy.
Cash.
Okay.
So we're trying to find this net force. But we also have to find this angle.
So we
Because
found
it's
the,
not on the x or the y direction.
so we need to find the angle
So
first?
you can use inverse tangent.
Yeah.
Yes, I'm going to use the inverse tangent, and then I'm going to use the Pythagorean theorem to find the net force in the x direction.
How unfortunate.
Okay?
Okay. We'll continue on.
We'll pick up on this tomorrow.
So
We'll pick
then,
this up tomorrow.
so then it would be that divided, it's like 64 divided by the 46 points? Or not? Yeah.
Yeah. And then you take the inverse tangent of that. And that'll give you what you're looking for.